Good morning, everyone. My name's Dr. Craig Warren. I'm a senior lecturer here at Northumbria University in Newcastle in the UK. Welcome to this workshop, which is about ground penetrating radar modelling using gprMax. I'm hosting this workshop along with Dr. Antonis Giannopoulos and Dr. Giannakis, who you can probably see and you will hear from shortly. Antonis works as a reader at the University of Edinburgh, and Iraklis is a lecturer at the University of Aberdeen. We had originally planned this as a rather small face-to-face event, which was going to take place back in April in Newcastle. And obviously due to the coronavirus pandemic, we had to postpone that. And in turning it into an online event, I have to say we've been rather overwhelmed by the amount of interest, to be honest. We've had almost 320 people register for this event, which is fantastic to see, and really interesting to know how people are using gprMax or how people want to use gprMax. So we've got 3 days of presentations and workshop sessions planned, and I'm delighted to say that we've got a range of different speakers from academia and industry, some of whom you can see in our panel at the moment. And I'd like to thank them on behalf of Antonis and Iraklis and I for giving up their valuable time to come and talk to us, and I'm really interested to hear some of the things that they're going to have to say over the next few days. So you're of course welcome to drop in and out of the workshop as you like. You should have had been emailed a copy of the program, so you can choose the different sessions that you'd like to attend. There's no expectation that you're going to be sitting behind your computer for the full 3 days. Essentially, today is kind of an introductory session. We're going to cover some of the theory and underlying concepts that underpin gprMax, and then we're going to go through some simple modeling, and then we're going to finish off the day by hearing from one of our speakers who's had some experience in industry and get some perspectives on using gprMax and GPR modeling from industry. So we're recording these sessions where we have permission from the speaker to do so, and we'll give details after the event about how you can access those. Just some kind of brief housekeeping information. Obviously, there's quite a few people in attendance, over 100 at the moment. So we will try and keep any questions that you have, if you can put them through the chat window. There'll be one of the hosts kind of monitoring that throughout the session. So we will put your questions to the speaker, or we can keep them for the end of the session, and they can be answered then. We also have tomorrow, I think it's just before lunch, a kind of dedicated time for questions. So if you've something a bit more specialized or detailed that you'd like to ask one of us, then you can probably save it and do it then. And also you'll see there are sort of regular breaks in the program for you to take. So that's really all I have to say at this point, other than to just wish you enjoy the workshop, and you know, I hope that you learn something from it. And I'm now going to hand over to Antonis, who may like to say a few words before he begins his first session.
Okay, thank you, Craig. Welcome everybody from myself. I have to fill in 20 minutes before the 10 o'clock session. That's okay. I can fill any time really. I think. Just again to send a warm welcome everywhere and everyone. I don't know, there are different time zones and people from all over the world that actually joining this. And as Craig said, we had this idea to run a face-to-face small workshop at his place in Newcastle. And then obviously the madness ensued for all this world that was suffering for the last few months, and everything locked down and we closed and we're all staying at home and working through the amazing technologies of video conferencing, and everybody's online. So we thought to have this small idea to actually try and do something this summer. Since actually all the events that we used to go, conferences and meetings and all the things that brings communities together to discuss what they're doing and actually meet people and see how they are as well, they've been cancelled. So everybody's pretty much on his kind of own place really. And maybe that explains a little bit more of the demand as well for this workshop from what we had anticipated. Nonetheless, it's quite a nice thing to be able to host. As Craig said about the program, we have a mixture of all sorts of levels and discussions about the general use of gprMax, so general use of GPR modeling and how we can incorporate it both in your practice or both mostly on your research and increase your understanding. What we start on today and what I will go to do is motivated a lot by the fact that I see a lot of people in the forum that we have, but even in presentations and other research aspects of the work, trying to use the simulator, but without understanding key fundamental concepts of how is built, what it can do. And most importantly on these things is not what the simulator can do, but is what it cannot do. And that is the biggest problem that we have often, is people don't understand the limitations of whatever numerical tool they use. I used to tell my students is the moment you trust the numerical model completely is just you put a first step above the abyss and you're going to fall into the big cavern underneath. It's always have to be aware about the limitations of your underlying tool because that allows you to have confidence of what you're going to get. So it's important to go through the basics and understand how the underlying method, the finite difference time domain, which is basically what we use to solve and simulate the GPR problem, is actually working. Now, there are a lot of mathematical equations, unfortunately, on these kind of things. However, as far as if you understand addition, subtraction, and some simple division kind of thing, everything will be okay, because the finite difference time domain method is a very simple one, and you just highlight the physical key concepts. We're not going to go through the whole detailed modeling of what gprMax can do, because that will take days, but at least we'll be able to understand and clarify specific things. If I was back in my office, I would have produced the first manual of gprMax, which I have in hard copy, which I gave to BRE, the Building Research Establishment in the UK. Unfortunately, around 1996 or 1997, I'm too old now to remember that. So we've been around for a very long time in various different ways. But the last, I will say 5-6 years, through the work of Craig and Iraklis and Ria and the younger people in a way, and the ability to actually rebase and redevelop gprMax to what is today, which is a lot more flexible, better, powerful, and with a lot more features that you used to have. So it's such a great thing to see that actually a lot of more people trying to use that in the research and in daily practice as well. Now, I think we do still have 50 minutes to go for the program, Craig. Shall we maybe start early since we have people here, or shall we wait a little bit longer?
Yeah, I mean, we kind of anticipated we might have some technical hitches, so we built in, I think, a bit more time than we've actually needed this morning.
Shall we invite the other people on the panel to actually say a few words of who they are, what they are? There are faces in the wall now, so let's do that before we start.
Yeah, that would be good. Shall we start with Andy? Do you want to introduce yourself?
Mic switched on again. So I'm Andy Cartage. I'm working with GPR for quite a while. And we have all met at several different places in the world in analog activities. Now we are fully converted to bits and bytes. I'm using gprMax for a while now in order to evaluate survey problems. Before going on sites with unknown details, we like to have a basic view on is GPR a good idea or not, and if it would be a good idea, how would the data look, how would typical target patterns look in the data. So it's for us a very efficient tool to save trial and error in the field and to focus on essentials when we start collecting data. So what else? My first models were real analog at Delft Geotechnics, the big water tank. We modeled the scattering behavior of spheres and cylinders radiated with 900 and 400 megahertz antennas, and the tap water helped to scale down the size of the experiments. But this was the fate of curious people some time ago. And since we have gprMax, we are in a position that we do these things more efficiently, faster, more flexible, and it's a very brilliant tool. And tomorrow I will show you some application which are mainly on 2D for, let's say, daily life civil engineering applications. Thank you.
Brilliant. Thanks, Andy. It's interesting that when we talk about modeling now, we generally think about it as numerical modeling and not actual, physical models. So it's nice to remember that, we can still do that. So I'm just kind of working my way down the list of panelists here, and next on the list is Anya. Don't know, can you hear me, Anya?
Yeah.
Good morning.
Good morning.
Do you want to introduce yourself and kind of say a bit about the exciting things you do?
I try to. Hi everybody. I'm Anya. I'm working actually in Jülich and together with Jessie, actually, she's also on the panelist. And we are working on GPR for waveform conversion also since a while now. And we do this for crossroad applications, surface applications, and I think more than 5-6 years now, we try to use actually gprMax as our forward model to improve our inversion results in the end. And one important step there was actually that we go now for 3D modeling, especially for the crossroad applications, to get really rid of some assumptions that we are doing there. So I'm talking a bit more about that on Friday, actually, how gprMax helped us there with the 3D models, but also how we can now use antenna models in there to really improve and enhance our inversion results, which is, of course, for us, highly computational expensive. But with all the new developments of the last years, that helped us always to go also for the next steps, also in terms of to keep the computational costs low as possible, that we can still run the things. But also we go now, for example, also for the surface applications, where we now can also include different models for the gprMax, also antenna models in there and all of these kind of things. So yeah.
Great, thanks, Anya.
Sure.
And it's interesting that we can easily run more simple models now much faster, but on the other hand, we can always think of bigger models to tax even the latest computing facilities that we've got access to. I see the order of my list is changing, which is confusing me, but I'm going to move to Jessie next.
If I can just butt in and say to Anya, in terms of the big models, when I was doing my final models in my PhD, maybe a few years ago, not that many, the admin of the main computer of the York University where I was used to kill my jobs and send me an email and saying that I'm not a very good sociable person because I'm trying to use half the machine on my own, trying to use 24 megabytes of RAM. That was 24 megabytes of RAM that it will take and a 100-cubed small model to run, and it wouldn't run. Now things have changed for the better, which is a good thing.
Yeah. I make no comment on that, Antonis. I think it's best I don't say anything. Jesse, I guess it kind of makes sense to talk to you next, since you're working with Anya.
Yeah, as Anya already said, we are doing GPR full waveform inversion in cross-hole setups and surface setups. And yeah, I'm working with her as a PhD student at the research center in Jülich. And my job is more or less to do the surface modeling using gprMax as a forward model.
Great. Thanks, Jesse. Iraklis, as our co-host, do you want to say a few words?
Hello from me as well. So my name is Iraklis Giannakis. I'm a lecturer at the University of Aberdeen. I have been using gprMax the last 10 years. And the last couple of years, I'm using gprMax for machine learning applications because training data are very important for machine learning. And in order to create a coherent training set, numerical modeling can help us a lot. And gprMax is fine-tuned for this purpose. I'm going to have a presentation at the third day about it. And this is why I'm very involved with numerical modeling. So I want to welcome you as well. And thank you very much for attending this workshop. And I hope you enjoy it.
Great. Thanks, Iraklis. Anya, would you like to introduce yourself and give a little bit of background as to what you're doing?
So hi everyone. I'm sorry, it's the first time that I'm using Zoom. I hope you can hear me. I am Anya, and I'm a PhD student at the University of Edinburgh in the School of Engineering. And I'm working along with my supervisor, Dr. Giannopoulos, on machine learning techniques applied to different kinds of GPR problems that have to do either with filtering or target recognition. And of course, for machine learning, we need a large amount of data that we gather from simulations, of course. And that's why we use gprMax to actually create these simulations and to create numerous models fast. Thank you.
Great, thanks, Rania. And I think you're talking tomorrow afternoon, aren't you?
Yeah.
So we'll hear some more details then. Philip?
Yeah, hi from my side. So my name is Philip. I'm working at the University of Potsdam, basically as a doctoral student, and in a working group which is, let's say, not that familiar with GPR modeling since. So what I use gprMax for is, so we're basically focusing on sedimentary problems or exploring sedimentary systems in the field. And so what I did in the first years of my PhD thesis is I used gprMax to model quite extensive and densely sampled GPR data sets in 3D. So basically to help us improve the typical processing and interpretation techniques we use to analyze and explore such sedimentary systems. So tomorrow in the afternoon, I will show you how we use this novel GPU acceleration in gprMax to get some very large GPR data sets using basically our own workstations. Yeah. That's it.
Great, thank you, Philip. And last but definitely not least, Ria.
So hello everybody, I am Ria. I am a researcher at the Department of Geophysics at the University of Thessaloniki in Greece. And I have a talk this afternoon on the use of gprMax in industry. that is sensors and software. That my initial cooperation started way back in 2009 when I had just finished my PhD. And from 2013 to 2018, I lived in Canada and worked for the company. Currently, we have an active cooperation into various research projects. So I'm working in the area of GPR development and application to a range of geophysical and engineering problems, trying to solve to do environmental monitoring, non-destructive testing, archaeological prospection, and so on. So I use the numerical modeling and more specifically the FTDD technique and its application to numerically model GPR.
Great.
And I will try again to start my video, but I'm not sure why it's not behaving.
You're destined to be anonymous. Yeah, thanks everyone. I mean, it kind of demonstrates, I think, the sort of variety of different backgrounds and applications and ways in which people are using gprMax, and I think it's going to be really interesting to hear from everyone.